What Earth's melting permafrost means: homes, highways, rail lines, pipelines, and runways can crack, buckle, tilt, or fail entirely. Landscape deformation. In some areas, thawing produces the drunken forest effect, where trees lean at unnatural angles because the frozen ground beneath their roots has turned into unstable sediment. Coastal regions face an additional threat. In Arctic communities, permafrost often helps bind coastal bluffs together. As it thaws, coastlines become more vulnerable to wave action, storm surges, and erosion. Some northern villages are already confronting difficult questions about long-term habitability, managed retreat, and relocation. These are not abstract engineering concerns. They affect homes, transportation networks, energy systems, emergency access, and the cultural survival of communities that have lived in these regions for generations. Biological risks and ancient pathogens. Permafrost functions as a natural freezer, preserving not only plants and animal remains, but also microorganisms. Scientists have identified ancient bacteria and viruses in frozen layers that have been isolated from the modern biosphere for thousands, and in some cases tens of thousands of years. As deeper layers of permafrost thaw, there is concern that dormant biological agents could be released into modern ecosystems. Potential biological risks include resurrection of ancient pathogens. Previously frozen bacteria or viruses could re-enter the environment and affect wildlife, livestock, or human populations. Limited immune familiarity. Modern species may have little or no evolutionary exposure to some of these organisms, potentially increasing vulnerability. Monitoring and containment difficulties. The Arctic is vast, remote, and difficult to monitor. Detecting biological risks early is a major scientific and logistical challenge. It is important not to exaggerate this risk into science fiction. The probability of any single ancient pathogen causing a major outbreak remains uncertain. However, the broader concern is real. Thawing permafrost changes the biological safety profile of northern environments. It opens previously sealed ecological archives and reintroduces uncertainty into systems that were once locked away by cold. Environmental toxicity and ecosystem disruption. The ecological consequences of permafrost thaw are equally serious. Many northern ecosystems depend on the unique hydrological conditions created by frozen ground. When permafrost melts, water flow patterns change. Lakes may drain, wetlands may expand or disappear, and river systems may receive new pulses of sediment, nutrients, and contaminants. One major concern is the release of pollutants previously trapped in frozen soil. Environmental hazards include mercury mobilization. Permafrost stores significant amounts of mercury, which can enter waterways as thaw progresses. Food chain contamination. Once mobilized, mercury and other pollutants can accumulate in fish, birds, mammals, and ultimately human communities. Threats to indigenous food systems. Many indigenous peoples rely on local fish, wildlife, and plants for nutrition, culture, and identity. Chemical contamination and ecosystem disruption can directly threaten food security and cultural continuity. These ecological changes extend beyond the immediate thaw zone. Altered water chemistry, shifting vegetation, changing wildlife patterns, and contaminant release can reshape entire northern landscapes. The environment is not only losing its physical stability, it is also losing part of its chemical and biological predictability. Synthesis, a destabilized frozen vault. Thawing permafrost is not a single-issue environmental problem. It is a complex crisis that links climate feedbacks, infrastructure collapse, coastal erosion, biological uncertainty, toxic release, and ecosystem disruption. Its significance lies in the way these risks reinforce one another. Area of impact, primary risk, wider consequence. Climate, carbon dioxide, and methane release accelerated global warming. Infrastructure, ground subsidence, and instability damage to homes, roads, pipelines, and public services. Coastal regions, erosion of thawing bluffs, displacement and relocation pressures. Biology, release of dormant microbes, uncertain ecological and health risks. Ecosystems, mercury and pollutant mobilization, food chain contamination, and biodiversity stress. The thawing Arctic ground is therefore not merely changing from solid to liquid. It is transforming from a stabilizing planetary feature into an active source of risk. Addressing this crisis requires an integrated response. Global emissions cuts remain essential because limiting warming is the only way to slow large-scale permafrost degradation. At the same time, local adaptation is urgently needed. Improved engineering standards, community relocation planning, indigenous-led monitoring, ecosystem protection, and expanded scientific surveillance. The permanence of the permanent frost can no longer be assumed. As the frozen ground gives way, the world must adapt to a more volatile reality, one in which the Arctic is no longer a remote climate indicator, but an active driver of planetary change.